Hi, in this video, we will introduce about the sound measurement by using the sound level meter. There are many reasons for carrying out noise measurement in the industry. First of all, we would like to know if the noise level in our working or living environment are safe or is dangerous or high enough to lead to the permanent hearing damage. Previously, we know that the limit for the LAEQ, which is the AVIC equivalent sound pressure level, should be less or equal to 90 dBA. This limit is recommended by the ORSA and also the ISO standards for a guy who works 8 hours per day. Nowadays, the standard is getting more strict. As you can see, the LAEQ over 85 dBA for an 8 hours working day should be investigated further. This restriction is to provide better hearing protection to the workers. If the sound that you measure exceeds the limit that is recommended by the standard, then user will have the basis to determine whether they need to apply the noise control strategy in order to solve the noise issue. By doing that, they can ensure the noise level are not disturbing to third parties such as the residential area. Besides the sound pressure level measurement, sound radiation or the sound power from single machine can be measured to confirm the value stated in the product's noise declaration. In practice, the sound power of the machine in the site can be measured indirectly by the sound intensity measurement. This is the sound measurement history where you can see in 1878, the Lord Rayleigh developed and established the theory of sound which laid the foundation of modern acoustics. The measurement of sound pressure level is possible with the invention of sound amplifier and the condenser microphone in 1906 and 1915. Olsen developed a device that can be used to measure the sound intensity. This is the pattern for the device. However, this device is only suitable for the measurement in idealized conditions. The first commercial device of the sound intensity meter is successfully made in 1977. As you can see in the picture here, the sound intensity measurement involves two microphones that combine together. This is known as the sound intensity meter. Fahey and Chong are the guys who developed the corresponding digital signal processing technique in order to realize the sound intensity measurement. Nowadays, we have more accurate sound intensity meter where the space between two microphones are made into smaller and smaller for a reliable sound intensity measurement. In this study, we will only focus on the sound pressure level measurement by using the sound level meter. Sound intensity measurement by using the sound intensity meter will not be discussed in this chapter. For accurate sound measurement, we must know how to correctly choose the equipment and also how to use it correctly. This is the picture for the sound level meter, which can be used to measure the sound pressure level. The sound level meter consists of the microphone, which is the transducer. The microphone will convert the incoming sound pressure into electric signal, which can be processed inside the sound level meter, which consists of various electronic circuits. Inside this circuit, the sound pressure signal will be processed through some signal processing and the measurement result will be displayed, as shown in this figure. In simple, a basic sound measuring system consists of the microphone, processing section using the electronic circuit inside, and lastly, you have the readout unit. To correctly choose the device for the sound measurement, we need to consider the type of noise such as the steady noise, time varying noise, and also the pure tone noise. Besides that, we need to consider the accuracy required. Either is for the precision measurement that involve control and standardized measurement conditions, or is a preliminary survey for site works or under field conditions. Lastly, we need to consider whether it's a quick field measurement that require portable and battery operated instrument, or is for the long-term survey that require permanent installed equipment. 4 types of sound level meter can be found in the market. Type 0 sound level meter has the highest accuracy in terms of sound measurement, where you can see the magnitude can be measured up to plus minus 0.7 dB. Type 1 sound level meter has lesser accuracy, followed by Type 2 and Type 3. We usually use the Type 0 for lab work, which require the highest accuracy, and we use Type 2 and Type 3 for the fieldwork. Type 1 is chosen if it is intended to be used subsequently between the lab work and also the fieldwork. The description given here is simple guideline for us to choose the meter accuracy. In actual, the accuracy of the sound level meter depends on a range of factors, not only the magnitude resolution as shown here, but the accuracy of the sound level meter is also affected by the frequency content of the sound. So you can see the incoming sound might be coming from various directions, and this will affecting the accuracy of the sound level meter. Since the accuracy of the sound is depending on a lot of factors as discussed here, therefore it's impossible for us to provide a precise overall figure that consider all the factors to decide the accuracy for each type of sound level meter. For simplification, we can just use the Type 0 till the Type 3 here to decide the accuracy of sound level meter. Regarding the sound pressure magnitude, we have learned previously that the average value is not suitable to quantify the sound pressure magnitude. As you can see here, the positive region will cancel off with the negative region to obtain zero average here. The most commonly used sound pressure magnitude for harmonic or random noise is the RMS value instead of the average, where in this figure you can see when you take the p-square, you obtain the blue curve, and the negative part can become positive. Then you can continue find the p-square mean, which is given in the red color, and then take the square root to obtain the root mean square. Root mean square value is very useful because it is related to the energy content of the harmonic or random noise. For impulsive sound, we frequently use the magnitude of peak or the peak-to-peak. We can relate the root mean square and peak by using this formula. You need to be careful. This formula can be used for sine wave only, and it cannot be used for the impulsive wave.